sides are divided into segments that are proportional. So here's what that means. In this picture, there are two different triangles. There's the smaller triangle on the top, and then there's the larger triangle that's underneath. So it's like laying on top of it, right? You've got an overlapping triangle in this picture. So here's my small triangle, BDE. Okay, there it is in pink. And then I've got a larger triangle, ABC, right here. Okay. So the side lengths of these, two triangles are going to be proportional, which means they're going to have the same ratio, the same fraction. So if I take a look at the pink triangle up here, one of the side lengths of this pink triangle is on the left here. It's side length BD. If I want to find the side length that is in the same position or corresponding positions to side length BD on the purple triangle, that is side BA. It's the whole thing. So the ratio of this pink triangle to the purple triangle should be the same on the left as it is on the right. They should be the same proportions. So on the right, what would my proportions be on the right side? BE and BC. Very nice. So it's the small triangle divided by the large triangle. You also we could flip it, right? We could do the big one divided by the small one. It doesn't matter because they're fractions, but it's like whatever you pick for the first one, you have to pick the same pattern for the second one. You can't switch. The converse of that theorem says literally the opposite. So it says if you have these sides being proportional, then you must have two parallel lines. So it's literally just the opposite of the sentence right up here. That's what converse means. It means you just flip the sentences. So if BD divided by BA is equal to BE divided by BC. So if your side lengths are proportional, then side DE is parallel to side AC. So it's literally the same sentence, just whoop, flipped. Okay, so we're going to practice writing some proportions. And then not only writing the proportions, but also solving for unknown side lengths. Okay, so we're gonna do let's do the even problems together. Okay, excuse me. All right, let's take a look at number 2. So you've got the smaller triangle on top. So I'm gonna highlight my smaller triangle pink, and I'm gonna pick one of the sides of that pink triangle. So what is one side length of that pink triangle? 56. Great. Now I have to divide that by the same side on the purple triangle now. Now the purple triangle is the whole thing. So 77. Good. And how'd you get that, Joe? Yeah, you just add the two together. Exactly. So 56 and 21 gives you 77. Now I have to keep that same pattern. I'm going to go to the other side and make another fraction. What would my fraction be on the other side? What number will go on top? X, because that goes along with my pink triangle. And now what am I going to put at the bottom?
X plus 18.
Perfect. X plus 18 or 18 plus X. Exactly. Because you're going to have to add those two pieces together. Okay. And now we've got cross multiplication or butterfly, whatever we're calling it. So let's do a little bit of cross multiplying here. 77 times X is 77 X. You get a what? Okay. 56 times X plus 18 means I have to take that 56 and distribute it to both the X and to the 18. So what's 56 times X? 56X. And what is 56 times 18? 1008. Good. And now, friends, it's your favorite. Algebra. Hooray! What should we do?
Take the 56 and subtract it. 56.
Good. Minus 56 on both sides. 56x. So you get 21x equals 1008. And then divide by 21. You get x equals 48. Done. So it's a lot of algebra, but the only really important part of this whole thing is making sure that whatever proportion you pick for the first one, you pick the same proportion for the second one. If you decided to do the purple one divided by the pink one, big divided by small, that's fine. You just have to keep it the same for both, okay? What questions can I answer so far? None? Not one, huh? Don't all jump up to say something. I know that it's an exciting Monday. You're all really happy to be here. You all look very excited today.
I'm ecstatic.
So happy to be here. Okay, number 4. I'm going to show you another way to do this problem. Okay. I've got the pink triangle, so I'm just going to kind of get in the habit of making a small triangle and then highlighting my big triangle. So if you look at that pink, the small triangle, what is one of the side lengths of that pink triangle? Something that's marked for you. X is marked for you. Great. Now, instead of me doing the small triangle divided by the whole thing, I'm going to make a proportion instead that is this piece divided by the same piece on the same side. So instead of doing the whole thing, I'm going to use just the number 7. So I'm going to use x because that's one piece of that side, and then the 7 is the other piece of the same side. So x divided by 7 equals, now I'm going to do the same thing on the opposite side. Now there's no number over here. What is this pink piece that's got no number?
21.
21. How'd you get that?
Because the whole thing is 27, and then you have a little 6 segment.
Yep. So you just, like Shreen said, we just subtract the 2. So what would my second fraction be?
21
Over?
over 6.
Over 6. Perfect. And again, it's cross multiplication. So x times 6 is 6x. 7 times 21 is what? 147. And then I divide by 6 on both sides. 0.5, right? Not really, but okay. Would you rather have 50 cents or 60 cents? Yeah, right. So not the same. Okay.
No.
What questions can I answer so far? So there's a lot of different ways to write the proportions. As long as you keep the pattern the same, you're good to go. Okay. Let's write the equation for number 6, and then I'm gonna let you do that one on your own. Who can help me write the equation for 6? Who wants to give it a shot? Go for it, Chella.
All right, so we can do on the left side first.
Okay.
So we got that triangle.
Mm-hmm.
So we can do 21 over 6.
Okay.
And then root x plus 1 over x.
Beautiful. So that's one way you could write it. There's another way to write it. What's another way to write it?
27. We can do 21 over 27.
Okay, so you can do 21, this small piece, over the whole side length is adding the 2 together. So that's 27.
We can
And now if you're going to do that, you have to keep the same pattern on the right. So what would match up with the 21? 3x plus 1. Now for this one, you have to do the whole thing.
So can I simplify it?
You can simplify. What would that be? It would be just 4x. Yeah, the ones would cancel, and 3x and x gives you 4x. Both of these problems are going to give you the exact same answer. It does not matter how you choose to do it. So pick one, and underneath where you got some space, do that problem. I'm going to walk around and check it. So give yourself a few minutes. Try number 6. And if you're already finished with that one, you can go back to the odd numbers because I'm not doing those with you. So you could do 1, 3, and 5 if you're already done.
Can we get negative?
No negative.
Negative answers or negative?
No negative x values.
Like throughout the whole problem? Or just at the end?
At the end, no negative x values. Yeah, and decimals are fine. If you got decimals going on, that's cool too. So you do it, pick one of the ways. I'm going to show you the answers for both. Oh man, I didn't want to actually show it yet. Stop, don't move. We're gonna go down to the odd ones because you're gonna be doing the odd ones for homework anyway, so you might as well jump in on that. Well, you did not.
Wait,
This is x minus 1, that's one. Good. Plus. Ooh. This side? 3x times 6 is 18. X 6 times 1 is. Oh, 6, not 7. Oh, yeah. I don't either. Hmm. So if you're gonna, when you multiply, you have to take this number, it has to multiply by both the x and -1. So 21 times -1 is -21. And he made a mistake on the other side too. That's why it's not working out. You get what? Yes. No, that's all.
I didn't know if you were gonna.
I think one of those is not, but I actually one of those seems a little big. Like the first one seems very large.
First one?
Yeah. What did you get? 105? Oh, it's not that big.
Wait, is it 32.7?
For the very first one?
Yeah.
I got 17.5.
What? Are you wrong?
I don't think I'm wrong. I mean, there's a small chance, but I don't think so. All right, check your number 6 with mine. So look, I did it 2 different ways. I showed you both. I gave you both different equations. I don't care which one you decide to do, but whatever pattern you pick, you just got to keep it the same for both. And additionally, I saw a couple people do this. Please remember, when you are multiplying a single number by an expression, you have to multiply it by both the x and the -1. If you only do it for one piece and you're not doing the whole multiplication, you're not going to get the right answer. Okay? So make sure you're distributing to everything. Okay? All right, let's take a look at number 8. And then let's take a look at that last section there. Okay, questions so far? We feeling okay? I think half of it's just being careful of the algebra, you know? Once you get the algebra, that should feel pretty easy. Okay, for numbers 7 through 9, you're going to determine if line MN is parallel to line JL. So here's what we're going to do. We're going to write proportions, and we're going to see if the proportions are the same or if they're different. If the proportions are the same, like what this theorem says, that means my line should be parallel. If they're not the same, again, they're not parallel. So it's just a little bit of division for each problem. So let's take a look at number 8. Excuse me. I need to write 2 different ratios for number 8. Who can give me one of the ratios? Not Jello, because he's answered everything today. But I appreciate you a lot. Someone else who can give me one of the fractions. Ezra, thanks for making eye contact with me for a second and then looking away. Why don't you give it a try? 15 over 19 and 18 over 23. Okay, beautiful. So you can do piece to piece or you can do piece to whole, which is what they just did, piece to whole. Okay, all we got to do is divide. That's it. We just got to divide and see if they're the same or if they are different. So 15 divided by 19 gives me 0.789. And 18 divided by 23 gives me 0.782. Are they the same? No, they are not the same ratio. So what does that mean? Not parallel. Good. Good, good, good. Okay, easy peasy, right? I can skip 7 and 9, yeah. You can do just a little bit of division yourself. You don't need me.
Are you guys going for the next portion?
Yes, that's what I'm gonna do now. You're okay. All right, questions on that? Any of that piece so far? We feeling okay? It looks like what I'm seeing is everybody's proportions are set up nicely. It's just the algebra that's getting some people tricked up. So be very careful when you're doing your algebra. I like the proportions. That's more important to me anyway. But just be careful when you're doing your algebra. Okay, last section says proportional parts and parallel lines. It's essentially the same thing as what we just did with the triangles, but instead of it being like a closed shape, just think of it as the triangles being opened is the only difference here. So this theorem says if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So in this picture, you have 3 parallel lines. What are the 3 parallel lines in this picture? What's one of the parallel lines in this picture?
AB.
AB, great. This one is a parallel line. I know it because it's got an arrow on it. What's another parallel line?
CD.
CD is also parallel because it's got the arrow on it. And these actually really should have arrows, but.
Yeah.
And EF. Good. So these are my 3 parallel lines. The other 2 lines are your transversals. So if you want, I'll call this one T1, transversal 1, and I'll call this one T2.
So does that mean like you say angle A?
So it's not going to be angles. We're going to do sides because we're talking about proportions. So that means the 2 pieces that make up transversal 1 should be equal to the 2 pieces that make up transversal 2. So on transversal 1, my first piece is A to C. My second piece of that transversal is C to E. So those are the 2 pieces that make up my first transversal. Those should be equal to BD and DF. Perfect. The other 2 pieces that make up my second transversal. So you do have to pick 2 numbers that are on the same transversal. So it might be smart of you to label transversals T1, T2, because that might help you out when you're looking at your picture so you don't get confused. So why don't we look at number, I don't want to do all of them. I'm only going to do one with you.
Me too.
No, I'll do one. Beggars can't be choosers. Let's do number 13 because the rest are, those ones before are easy. Let's do 13. Okay, I'm going to label my 2 transversals. So this is one transversal. I'm going to call this T1. And then I'm going to label the other one as T2. Okay, so I need to pick the 2 pieces that make up transversal 1. What are the 2 pieces that make it up? So this one on the left. 2 numbers that make up that line are what? One of them is definitely given to you. 28 and 64. Good, because the other piece that makes this one up is 64. It has to add up to give me 92. So I've got 28 is one of them, and 64 is my second one. Now I have to go in the same order for transversal 2. What would be the same order?
31.5 and 60.
Perfect. Okay, now what do? Cross multiply. Yeah, so look, the hardest part is just setting up the proportion. After that, it's pretty quick and easy cross multiplication. So 28 times x is 28x. And then 64 times 31.5 is 2016.
When everything was okay.
I was going to say, what a year to be alive that was. And then I'm going to divide both sides by 28. You get x equals 72. Okay. So we've got a little under 10 minutes left. You're going to finish the front for homework. And I'm going to come around tomorrow and I'm going to check off just like I did today. All right. I'm just checking you off tomorrow. So you've got the remaining, 7 minutes that we've got to work on the front. And then we'll tackle the back tomorrow. Okay. So take some time. And if you finish, I can check yours quickly. Yeah, give me 1 second. For which one? Right, so here's the issue. You went piece to piece, which that means over here you have to go piece to piece. So it's just 15 over.
Originally, I did that. And I got 32.8.
Negative.
How much of it?
A lot.
Well, I
Okay, well, so this should just be X. So if you're gonna, so you're trying to
Yeah,
do
I
like
tried something
two
different,
different equations in one. That's why.
so like,
Which I have a feeling you did for probably all of them.
wait, like that?
So 12, so you did small piece divided by big piece, small piece divided by big piece, yeah.
Okay, so maybe 14, whatever it is.
Right. There you go. And then the second one, you set that one up right. You did piece, 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 piece. So you did that one fine.
Okay.
It's not a race.
I was just
Stop.
asking. I was just asking.
It's not a race. Math is not a race. Some of the best mathematicians are slow, but they work through. That is a true statement. Because they think through processes a little bit longer and a little more thoroughly. There's a real true moment.
Did you get there already?
No.
Somebody.
So it's true though. Some of the best people who are the best at math just take a little longer to do math problems. It's not a race. How do I stop recording? You don't want to be in the recording?